Hello everyone, and welcome back to my SP2 channel. We're going to be looking at the stoichiometry and the chemical equations. I have kind of introduction to the chemical equations, how we can balance our chemical equations. There are a couple of simple patterns of the chemical reactions that we can look into that, and then just like always, I have a couple of practice for you at the end. Okay, so let's go over the introduction to our chemical equations. So here it says chemical equations are symbolic representations of our chemical reactions. They describe the process in which substances, which are known as reactants, undergo a transformation to produce our new substances known as our products. The equation provides important details and information about the identities as well as the quantities of our substances, and we always need to follow the law of conservation of mass. According to this law, atoms are neither created nor destroyed during a chemical reaction. And I just have an example here for you, which is a reaction of methane with oxygen. And on the product side, we have carbon dioxide and water. So I'm just going to copy this reaction for you on the next page, and then we can talk about all the details of this reaction. So follow me on the next page. Okay, so we're going to have our reactants, which are also known as your starting materials, right? And we always need to write them on the left side of the equation. Then we have the products that are going to be written on the right side of the equation. We are using a simple arrow, right, to separate the reactants from the products and also giving us the direction of the reaction. We always need to have stoichiometry coefficients as well, and these are the numbers that you place them before the formulas of both our reactants and products to balance out the reaction, right? Because we want to make sure that we are following the law of conservation of mass, okay? And as you can see, I've got, like if I want to read this reaction for you, it would be 1 mole of methane reacting with 2 moles of oxygen gas, and we are producing 1 mole of carbon dioxide and 2 moles of water. Okay, now we're going to be looking at how we can balance our chemical equations. So I want you to think about like method of trial and error, right? But there are a few steps that are generally speaking helping us in many of our cases. Okay, so looking at the same reaction that we have in our previous slide, we have the reaction of methane with oxygen gas, and these are producing carbon dioxide and water vapor. Okay, so at the moment, our reaction is unbalanced. Now, generally speaking, it's a good idea to start balancing those elements that occur in the fewest chemical formulas. For example, when you're looking at what I have here, there's only one reactant, and that is methane, that has carbon on the reactant side. And there's only one product, which is CO2, carbon dioxide, that has carbon, right? So I can balance my carbon. There must be one for each of these two. Now, it's okay to drop one. We typically don't write one in front of our chemical equations, right? So our carbon is not balanced. Next, we're going to focus on hydrogen, right? So we know that there's only 1 mole of methane, and that has 4 atoms of hydrogen. Okay, so we have 4 atoms of hydrogen on the reactant side. I need to have 4 on the product side. And that means I need to put 2 in front of water equation. So now we are balanced for hydrogen. Now, while our hydrogen and carbon is already balanced, it's not for the oxygen yet, right? So now it's time to balance out our oxygen. On the reactant side, you can see that we have 1 mole of methane does not have any oxygen. I need to figure out how many moles of oxygen gas we have. Looking at the product side, we have 1 mole of carbon dioxide where we have 2 moles of oxygen, right? And I have 2 moles of water, which is also giving us another 2 moles of oxygen atoms, right? So if you add them on the product side, we have 4. So I need to put a 2 in front of oxygen to balance it out, okay? So I can stop here, right? This is like perfectly balanced. Or you can actually take it to the next level where we try to add the physical state or maybe any specific conditions that the reaction required to happen. For example, for this case, I know that I have my reactants in a gas phase, right? Those are the two, common gases, methane and oxygen gas. I also know that my products must be in the gas phase, so I can add a G, right, for all 4 of these substances. Okay, now in this page, I'm going to show you what are our simple patterns for the chemical reactions. And then in our next few slides, we're going to be looking at all of them. So I have combination reactions for you. I have a little bit on the decomposition reactions as well as combustion reactions. Okay, so starting by combination reactions, these are the one that we have two or more substances that are reacting to produce one single product. I can write it as A plus B that goes to C. And we do have a lot of, examples. One of the really cool one is the reaction of magnesium with oxygen gas, which is producing magnesium oxide. That's the one that you probably have seen that in some of our fireworks. The next one is our decomposition reaction, which is pretty much the opposite. Now we have a single reactant that is producing two or more products. I can write it as C that goes to A plus B. And again, we have many examples. One of the really common one is where we have a metal carbonate, such as calcium carbonate, that is decomposing to a metal oxide, such as calcium oxide. And we also have the production of carbon dioxide. Okay, so looking at this table, this is just a summary table of both of these reactions, combination and decomposition reactions. And I just have provided some more examples just in case that you want to see more, chemical reactions for these two classes. Then we have the combustion reactions, and these are typically a rapid reaction that produce a flame. Most of our combustion reactions involving oxygen from the air as a reactant. So here I have an example, which is a hydrocarbon, such as C3H8. This is actually propane gas, which is very common gas that we use for like cooking, right? Reacting with the oxygen gas. And if I have them done, properly and like completely, we're going to have the formation of carbon dioxide and water. So we have CO2 and H2O on the product side. And this reaction is already balanced for your reference. Okay, so let's put them in practice, starting by this one. It says write the balanced equation for the combination reaction between lithium metal and fluorine gas. So lithium is Li, and since we have lithium metal, it's just the Li in a solid form. And then we also know that fluorine gas is a diatomic gas. So my reactants are going to be Li and F2, and then they are going to produce LiF, right, which is a solid. Then I need to balance it. I can see that I have F2 on the reactant side. There are 2 fluorine. I'm going to add a 2 in front of LiF, right? And then I also need to add a 2 in front of lithium to balance it out. Here is the second practice. Write the balanced equation for the decomposition reaction that occurs when solid barium carbonate is heated. And we also have a hint here. It says we have 2 products. One of them is a solid, the other one is a gas. Okay, so think about carbonate. You probably remember it's one of our polyatomic ion, right? CO3, and we have 2 negative charge for that. And barium is Ba, so you've got your barium carbonate, which is a solid, and it says we have decomposition reaction. So we are kind of breaking down barium carbonate into, it should be barium oxide, right? And we also have carbon dioxide. If you look at these reaction, every single atom is already balanced, right? Okay, cool, cool. Thank you so much for watching with me. If you found this video helpful, don't forget to give it a thumbs up. You can share that with your friends. If you're enjoying the content and you want to keep learning with me, don't forget to hit that subscribe button. You can turn on your notification bell so you're not going to miss out any of our future videos. I would love to hear from you guys. Drop a comment below if you have any questions, or maybe there's a specific topics that you would like me to cover that for you. Your support means the world to me, and it really helps this channel to grow. Thank you again, and I'll see you in the next one. Take care, and bye-bye for now.